All right, guys, today we're going to try something a little bit different. These are called doodle notes. So it's for a visual learner, but it's just a new way of kind of looking at notes. And at the end, I'm going to give you time to color these and make them your own and decorate them as much as you want. All right, so let's get started. Slope. Slope is the vertical change over a horizontal change, and it's represented by the letter M. So we have this letter M here, and M is equal to rise over run. Another way of writing that is to say that we're going to take the y coordinates. When we're finding the slope, we're finding the distance between 2 points. So we're going to do the two y coordinates. One of the y coordinates, subtract the other y coordinate. So distinguish between the two. I label them y2 and y1. We're going to subtract those, and we're going to divide that entire quantity by the subtraction of the x2 coordinate minus the x1 coordinate. So this is an ordered pair, and this is an ordered pair. So let me make sense of this real quick for you. Like, let's say I have a line that passes through 2 points. Passes through this one, passes through this one. This has an x coordinate and a y coordinate. This also has an x coordinate and a y coordinate. So when I say y2 minus y1, I just pick one of these. We'll label this one 1, and we'll label this one 2. So I do y2, take away y1, divided by x2 minus x1. And that gives me my slope. So slope represents the rate of change, and it should be written as a fraction. And when we write it as a fraction, we want to make sure that we put it in simplest form. So it's a fraction written in simplest form. All right, so what we're going to do is we're going to find the slope of each of the lines below. Scroll down here. The slope of a line can be determined from a table by counting units on a coordinate plane or by subtracting coordinates. So let's fill in the blanks here. Okay, so to find the slope between 2 points, what we can do is we can use that slope formula, or we can count. So let's identify where are the points 3, -2. So go over 1, 2, 3, and down -2. There would be a point there. And 4, 4. We could go over 1, 2, 3, 4, and up 1, 2, 3, 4. I'm going to put these points in there so that we can look at this as counting. So we said 3, -2, and 4, 4. So to get from here to here, the change in the y coordinate, well, I went over 1 unit, right? That's not my change in my y's, that's my change in my x. My change in my y's would be going from here all the way up to here. So I went up 1, 2, 3, 4, 5, 6 units, and I went over 1 unit. So I rose 6 units, rise over run. I ran 1 unit. 6 over 1 is just a slope of 6. Again, we could do the subtraction, y minus y. So 4 take away a -2 over, we did this 4 on top, take away -2. Now we're going to do this on bottom, 4 take away this on bottom, 3. So again, minus a negative is a positive, so we get 6 over 1, which is just 6. So you can look at it on the graph, or you can look at it using the slope formula. So again, if we're subtracting, we're going to say 0 take away a -1. I did this, take away this, over, since I used this one first, I have to use its corresponding coordinate on the bottom first. So 6 take away a -8. Again, a double negative is a positive. So I have 1 over, double negative is a positive. 6 plus 8 is 14. So my slope is 1 over 14. All right, so the slope of a horizontal line is always 0. Remember, slope measures the steepness. So if I have a line that's straight across, it has 0 steepness. That line is not steep at all, 0 steepness. The slope of a vertical line, it's so steep that it's undefined. The slope of a vertical line is undefined. And I'll post a little video for you guys to watch called SlopeDoodle. It's kind of funny. It's kind of so lame that it's funny, but I will post it for you to watch. All right, so plot a line that starts at the origin and has a slope of -3 and label it A. So let's look at this. Starts at the origin. Well, right here's my origin. Has a slope of -3. So if we make it a rise over run, that means -3 over 1. So we go down 1, 2, 3. That's going down -3 over 1. and we're going to label this A, it says. So here is line A. Plot a line that starts at 0, 4. Let's do it in a different color. 0, 1, 2, 3, 4. And has a slope of -3/4. So we go down 1, 2, 3, rise over 4. 1, 2, 3, 4, rise over run. So we went down 3 because it's negative and over 4 in the positive direction. And there is my line. It says label it B. So I have A and B drawn on here. If we want to get fancy, we can make them like block letters or something. I don't know. Here's my A and my B. And I never did go up here and calculate the slope of each of these lines. So let's go back and do that real quick. Looking at these, I go up 1, 2, 3, and rose 3, and I ran 2 units. So my rise over run is 3/2. Here, I rose 2 units. I ran 1, 2, 3, 4 units. So my slope is 2 over 4, but that can be reduced to 1/2. And let me show you. We go up 1 over 2, up 1 over 2, and I get the same thing as if I went up 2 and over 4. All right, and then the slope of this one, we're going down 1, 2, 3, 4, 5, 6 units. So down 6 over 1, 2. So -6 over 2, well, we know that we can divide that, and we get -3 over 1. Let's check it out again. -1, 2, 3 over 1. Down 1, 2, 3 over 1. So -3 over 1 is my slope, or -3. So M equals -3 for this line. All right. So remember, as we're going up and to the right, those are both positive movements. Going up is positive, moving to the right is positive. Going down and to the left, both of those are negative movements. If I go down, this was negative, but to the right was positive. A negative over a positive left me with a negative slope. Here, a negative over a positive left me with a negative slope. So that would be negative movements. Okay. So we have done all of these. Now let's move to this last thing. Steeper slopes have a greater absolute value. Steeper slopes have a greater absolute value. So why would we say absolute value? Well, if they have a greater absolute value, whether it's negative or it's positive, if they're steeper, they're a bigger number. So that's why we want to say taking the absolute value of it, because if it's negative, we think, oh, negative is a smaller number than a positive, and that's true. But when we're talking about a really steep slope like a -15, if it has a slope of -15, that's a really steep line. So if I take the absolute value of that and I say, okay, the steepness is 15, that's a very, very steep. It'd be like going up 15 feet and over 1. That's very steep. Whereas if I go up 2 feet and over 1, that's not nearly as steep as going up 15 and over 1. Okay, let's look down here at the bottom. I would like for you to pause the video and try some of this on your own. Okay, so I graphed my 4 different lines. You might have totally different lines. I would expect that you would, because you were to do this on your own. But they should all be going down as I move left to right. Okay, let's think about which one is steeper. What is the steepest line up here? It would be this one, right? This one with a slope of -6. If I think about that, that has a really, really steep slope. This one is the least steep of them all, and it's a fractional value. So if I put them in order from least steep to most steep, I would have -4/5 would be my least steep one, then the -1, then my -3, and my -6. So slopes will be represented with fractions with a greater absolute value. Absolute value, because again, we're thinking about them in whole number, or not whole numbers, but positive numbers. If I'm thinking about 4/5, -4/5, I want to think about it as 4/5. Compare 4/5 to 1 to 3 to 6. Compare their absolute values, and the one with the largest absolute value is the one that has the steepest slope. All right, so then it says sketch a sample or a few of each type of slope. So positive lines are going to have slopes that are going up as I move left to right. So we might be going steep, might be really steep, might not be so steep, might be more almost horizontal, but not quite. It's going up a little bit. So these are all lines with a positive slope. Lines with a negative slope would be going down as we go left to right. Again, the steepness may vary, but what makes it negative is the fact that it's going down as we move left to right. Lines with a zero slope are just horizontal lines, and lines with an undefined slope are vertical lines. Pretend that's straight up and down. Vertical lines have an undefined slope. Okay, and then the last part says order from steepest to least steep. So which of these would be my most steep? The 3 would be my most steep. Then next would be 3 over 2, right? Because it's like 1.5. So I've got this, then 3/4 or 1/3. Well, 3/4 would come next, and my least steep would be 1/3. So we have ordered them in order from least to greatest. Now, what I would really like for you to do, as I said before, is go back and color these, make them pretty, make it your own. I want to see really nice looking notes. You can draw on it, write whatever you need to. I think I have some examples maybe on here. Yeah, look at some of these really colorful ones. Make it yours. Be proud of it. Make it pretty. And I have markers in the cabinet. Hopefully I remembered to lay those out on the table for you guys. And that's all I have.